Hello everyone, you're welcome to our channel once again. Today we shall be discussing on how to calculate the exit velocity of a gas passing through a jet engine diffusers. Once again, how to calculate the exit velocity in meters per second of air passing through the jet engine diffuser as it decreases. Now, a jet engine diffuser decreases the kinetic energy of air entering at the inlet at 124 kilopascal and 38 Celsius with velocity of 481 meters per second and exited at 220 kilopascal 63 Celsius. Assume heat loss from the jet engine diffuser is estimated to be 5 kilojoules per kilogram. Now, we're asked to calculate the exit velocity in meters per second, taking the specific heat constant to be 1.009 kilojoule per kilogram per Kelvin. Now, let's pull out our parameters. Our parameter given, which is the Q out, which give us 5 kilojoule per kilogram. That gives us 5,000 joules. We have our T1, which is the temperature of the inlet of the diffuser, which is 38 plus 273, which gives us 311 Kelvin. Our T2, 63 plus 273, which gives us 336 Kelvin. Our inlet velocity, which is 481 meters per second. Our V2, we're asked to calculate our CP, 1.009 kilojoule per kilogram per Kelvin. Now, how do we calculate the V2, which is the exit velocity of the air passing through the engine diffuser? Now, by using the steady flow energy equation, which is Q1 minus QO plus W1 minus WO equals M, which is the mass flow rate over the variation of the entropy plus the variation of the kinetic energy and plus the variation of the potential energy. Now that we know that our QE is nullified, is not given, our variation of the work entry or coming in is nullified, is not given, our potential energy is nullified, is not given. Then we have our negative Q out equals M, which is the mass flow rate, multiplied into bracket of variation of entropy plus the variation of the kinetic energy of the diffuser. So therefore, don't let us forget that our M H2 minus H1, which is the variation of the entropy, equals the CP T2 minus T1. So that gives us our minus negative Q out equals CP T2 minus T1 plus V2 squared minus V1 squared over 2. Now let's pull in our parameters for calculation. So therefore our Q out, which is 5,000, which is negative 5,000, equals 1.009 times 10 to the power 3, which is the CP multiplied by 336 minus 311 plus V2 squared minus 481 squared over 2. If we interpolate all our V2 squared, we have 413.41 meters per second calculated. Thank you very much, which is the exit velocity.